Okay, so here's the latest casualty. This is a Seadoo 951 two-stroke. As you can see, this piston is in bad shape, although I've seen worse. What happened was the head gasket leaked and we had water ingress, which dilutes the oil and will seize things up. And what it didn't affect the cylinder too bad. What it really seized was the connecting rod at the big end. This is what's left of the connecting rod bearing. It literally melted. You can see this rod is screwed up big time. So, okay, so besides all that, these cylinders are worn out. The scoring wasn't too bad. That'll clean up pretty easily. But this is probably the original set of pistons. I think this thing had a little under 200 hours, and they're standard bore, but these are at the wear limit as specified in the Seadoo manual. So that's what I want to talk about more here. So this really shouldn't be too difficult. And what I'm going to use is a micrometer hone. That's really what the point of this video is. And I'll show you how you can do this yourself. So just to go over some of the numbers here, like I said, this is a standard bore, which is 88 millimeters. And I'm going to work in inches because that's what I'm familiar with, and that's what my micrometer is. So standard bore, 88 millimeters, is 3.464. The recommended piston clearance, a general rule of thumb, is 1/1000th per inch of piston diameter. So the piston is 3.459. So that's about 3.5 thousandths of clearance. So right now, the cylinders are at 3.468. So that's 4 thousandths worn over original. And right now, the cylinder at 468 is 9 thousandths beyond the pistons. And the wear limit is 0.0087. So, that rounds up to 9,000. So we're right at the wear limit. We're actually a little over the wear limit. So we're going to go 10 thousandths over, which is a 0.25 millimeter over. If you're looking at, most of these pistons are sold by the metric system. So the boring at oversize is going to be 10 thousandths over the standard. So that's 3.474 right here. The oversized piston, those will come in at 3.469. And I'm only working in three decimal places here, but there might be some other digits here. But that gives you, approximately 5 thousandths of clearance new. So anyway, we're going to shoot for closer to 3.5 to 4 thousandths. Now, I have done this before, and what I have found is the easiest way while you're doing this process, instead of taking 1,000 measurements, what I do is I make a plug gauge. So this is just a round piece of metal turned, and that is 3.468. And the thing is, I know it's round. It's not like using a bore gauge where this only gives you a diameter. And if you've used a micrometer and this kind of bore gauge, you know that everywhere around there you take a measurement, and up and down the cylinder it's going to vary a little bit. So that's what I like about having something like this. Now, this is turned a thousandth under the new piston size. So why did I do that? Just from experience. So if this just goes in, I'm going to have 1 or 2 thousandths of clearance anyway. That would be 3.470. The piston is 469. That's a thousandths clearance. I'm shooting for 3.5 thousandths. That leaves me a couple thousandths where I would then do like a finer honing process, and I will take micrometer measurements at that point. Okay, so this is the cylinder in our setup, but before we get on to the honing, I wanted to point out something very important. Being we're not actually boring, we're honing, and you have a worn out cylinder, you're going to have a ridge at the top, and the ridge has to be removed. The ridge is where the rings stop and the original wall of the cylinder remains. If you put the new piston and rings in, if they slam against that ridge, you're going to crack your rings. So if you're boring, the bore job is going to take that out, no problem. But to do this, like we're doing it, you have to use a ridge reamer, which is this tool right here, if you're not familiar with that. But that's just a very old school tool. Still the same. This is, there's 3 legs. They'll go in against the cylinder wall, and here's a carbide cutter, and you use a wrench, and it increments out a little bit at a time, and you just go around and it'll shave off that ridge. So we've already done that. I'm not going to show that, but just wanted to point that out. You have to do that, and the honing isn't going to take that off. It's probably going to just kind of ruin your honing stone, and it would probably caulk the stone in the cylinder and actually cause a tapered cylinder wall. So it's very important to get that out. Okay, so here is our cylinder in our setup. Right now the cylinders are about 6 thousandths under the next oversized bore size, which is 10 thousandths over. But we're not going to take the entire 6 thousandths off. We're going to just slowly creep up on it and hit the minimum piston to cylinder wall clearance, and we're shooting for about 4 thousandths. And the way we're going to do that is use this plug gauge, which is slightly under the piston size, the new piston size. And if I can get that to go, like I said, there'll be some clearance, and we'll start measuring from there. We're going to use the Lao micrometer hone, which you see right here. It's got a universal type shaft. This is really meant to use with a big 1/2-inch drill. We're going to use a drill press basically to give us even better alignment. The hone comes with coarse and fine stones. We're going to use the coarse to begin with. And there are 2, these are pads just to keep things centered. Okay, and this has 2 adjustments on it. This is a coarse adjustment, which is the bronze knob, and it has a bunch of holes with these pins that align it. As you can see, the stones and the pads go outward and inward based on which direction you turn. So you get that to where it's just fitting in your cylinder, and then on top there's like a vernier scale sort of, and that's a fine adjustment, which is the silver knob here. And it's a very fine adjustment, I found, and you can really control how much you're taking off. And with these stones, it takes off quite a bit. So this doesn't take long, and you want to just continue to check with your plug gauge to see what progress you're making. So that's that. And the other thing to mention is read the instructions that came with the hone. Now it says to do it dry, because if you use oil you're going to plug up these stones, and I have tried it dry and it works really well. I think what I'm going to do is, I can't really get a good 45 cross section because my spindle RPM is probably a little high. We should be around 400 RPM, but on slow speed I know I'm above that. So I'm going to finish, when I get close and I have about 1/1000 left, I'm going to use the typical old three-pronged spring-mounted hone with a drill, a hand drill, and I'll use some oil then, and I'll try to get the good 45 pattern with that. Another thing to note is this is mounted upside down, which is typically what you're going to do because the cylinder wears less at the bottom than at the top of the cylinder, and it's tighter at the bottom. And according to the instructions, you want to start there, and you want to try to take the taper out to get the cylinder straight, and then go from there. And the plug gauge would go, it would start into the top just a little bit, but in the bottom it's tight, it's not going. So we're going to show you how this works. I will say I have done a little bit on this cylinder, and I am getting the plug gauge to go very smoothly here. So I actually think I'm in good shape here, and that did not take long. Probably just a few minutes with this stone. I have a little more to do as I get towards the bottom, so I'm going to pick up there, and basically it's just the hone going around inside the cylinder. And I don't know if you'll be able to see, but it really throws off a lot of metal dust, so it really is pretty aggressive. So this could really work to take 10/1000 off, or even 20 maybe, which is kind of what we're doing. But I would say if it's much more than that, you really have to do a traditional bore job. Okay. Okay, so I'm going to start further on into the cylinder because I'm pretty good at the top portion. I don't want to take much more off there. And you want to set up your drill press stop so that you don't hit the carriage at the bottom. Alright, so we're just going to give this really, few seconds really. So I'm just about clear to the bottom, or actually the top of the cylinder with the plug gauge. So I might even flip this over and just touch up that very last bit of the cylinder. But I think I'll give it one more try here. But that is a really good fit. and I'm probably a couple thousandths over my plug gauge. Alright, it's just about flush with the top of this. It's actually coming through the top. So what we're going to do is flip this around. It's just a little snug right at the end of the cylinder, and I think I'll give it just a few passes right at the top from the other direction, and then we'll measure it and see what we got. Okay, so I've flipped the cylinder over, and I'm going to do a little bit at the top end of the cylinder, and we'll make sure the plug gauge fits smoothly all the way through. There you have it. Very good fit, and as you can see, it does not take long to remove material with this, especially with the coarse stones. So I'm assuming I have a couple thousandths clearance, which would mean this is 1/1000th below the piston, which would mean I have a couple thousandths clearance right now to the piston. But now I'm going to use the bore gauge and mic, and I'm going to be curious to see just exactly where we're at using this method. So I'm going to do that next, and we'll show you that. Alright, so here is the bore gauge, and I've tried it all around, and over the length of the cylinder it seems pretty uniform. So what I'm measuring is 3.473 and a half. So 73 and a half, and this was 468, is about 5.5 thousandths over this, which is a thousandths under, which is 4.5 thousandths clearance to my new piston. And that's actually perfect because the Seadoo manual calls for 0.0047 clearance minimum, and this would tell me I'm at 0.0045, and you know, in the fourth decimal place, you know, our measuring accuracy is nowhere near good enough at this point. So I have probably, you know, it's safe to say I've got 4/1000 piston to cylinder wall clearance. You know, the old rule of thumb of 1/1000 per inch diameter would be 3.5, so we're half above that, which is good. It's on the safe side, and I would say it's perfect. And really, all that's left to do is clean this up with the fine stone. Try to get some good cross hatching because this is a pretty coarse finish. I'm going to show you the what the cylinder looks like. But we will try to get, like I said, we'll get our good 45 degree cross hatching and get a little smoother finish on it, and we'll be good to go. We'll get the new pistons ordered and make sure we'll measure those and make sure they're correct. Okay, so we're going to show you what the cylinder looks like at this point. So you can see it's got circular score marks. Like I said, we want to get some 45 in there, but the scoring from this is the damaged cylinder, and I think it's safe to say that I've gotten the score marks out of this. It's going to clean up really nice with the hand held hone, and I think my clearance is going to be just right. And we'll finish up with, when we get it all back together, compression testing it and of course running it, and I'll show you that. Okay, so here we go with our compression test. This is the cylinder that was damaged. Alright, so that's 100 and at least 130, maybe even 135. That's really good for a DI. So that is very, very good. Alright, so we're going to do the other one. Yeah, original compression, they say should be around 120 on a DI, so that was really good. And this one I expect to be similar, and they should be within 10% of each other. So we're looking for, you know, 12 psi to 15 psi difference. So here we go. So there you go. 125 maybe. So that's within, you know, 5 psi. Excellent for a DI. So now we're going to run it, and I expect this thing to run really good. There we go. Fire right up. So I think everything's good, and we'll break this thing in and we'll be good to go.